Hello, everybody. We're going to talk about section 7.5 here. This is about solving trig equations. So we'll start with some kind of easier ones here first. They say find all possible exact solutions for the equation cosine theta is equal to a half. So my pen thingy going here. So here they do say find all possible solutions. That is going to be significant here momentarily. So if we look at the unit circle, if we want where cosine equals a half, that would be this distance right here, the x distance. And there would be another one, another solution just like it down below here. Both of these would be angles where cosine would equal a half. The sine value is √3/2, which is across from 60, also known as pi/3. And then the second angle that we're going to need is going to be the angle that is down here. If this is 2 pi, also known as 6 pi/3, if you back up and do negative pi/3 to back up that away, that means that the other angle would be 5 pi/3. And so the two angles that we need are going to be, the two main angles are pi/3 and 5 pi/3. Now, they do tell us find all possible solutions. That is a crucial point because, fun fact, each time you spin around the circle an additional time, you will still get a cosine of 1/2 if you keep spinning around and around and around the circle. One complete spin is 2 pi. So the way that you often see that written is they will say plus 2k pi. And then you would do the same for 5 pi/3, you would say plus 2k pi. Those are going to be the two solutions here. And the k is just a stand-in. And basically what it means, this is for k turns around the circle. So if you spin around once, that's going to be 2 times 1 times pi, where k is 1. So that's just adding 2 pi. If you spin around twice, that's k is 2, 2 times 2 times pi, also known as 4 pi. If you do negative values of k, that just means you're going to spin clockwise rather than counterclockwise, which is kind of the standard in the positive direction. And so anyway, k is just a stand-in variable that can stand for any integer, including 0. That's how you get the default solutions of pi/3 and 5 pi/3. And so by adding additional turns around the circle, that's adding 2 times k times pi. And again, k is just a stand-in for the number of times you would turn, and it would be negative if you went clockwise. For the next one, here we have sine of t is equal to a half. So sine is going to equal a half here. Here's where positive a half is. There would be another solution over on this side. This angle right here is pi/6. It's equivalent to a 30-degree angle. If this is your reference point of pi, also known as 6 pi/6, what that means is that if you back up pi/6, that's going to mean that the main angle right there is going to be 5 pi over 6. So then in this situation, again, they say to find all possible solutions. So for this problem, we're going to have pi over 6 plus 2k pi. And you're going to have 5 pi over 6 plus 2k pi. So those are just the basics. And here the big thing is just understanding two big ideas. One is that just like when you take square roots, you're going to have two main answers. Like you normally have a positive square root and a negative square root. With trig functions, when you solve them, you are often going to have two different solutions. And then if they say give all possible solutions, that actually means you're going to do this plus 2k pi where you're adding additional turns around the circle. Because as we talked about at the very beginning of the trig sections, you know, you can keep spinning around and around and around forever and still get the same trig values. So most of the time, what we're going to do is we're going to focus on just the solutions from 0 to 2 pi. They have it written in two slightly different ways here, but just know that these mean the same thing. In one problem, they wrote it as inequalities. In the other problem, they wrote it as interval notation. The thing to note is that this just means we're going to limit to one time around. So we're only going to go around the circle one time, going from 0 to 2 pi. So let's look at this first example. They say 2 cosine theta minus 3 is equal to -5. Now, even though this is a trig equation, a lot of what you know about solving equations is still true. So for instance, if I am subtracting 3, I'm still going to do what you would normally do. If you subtract 3, you would want to add 3 to both sides of your equation. Yes, that's not terribly surprising, I hope. So that just means 2 times cosine theta, -5 plus 3, that's going to equal -2. Okay, so far so good. Now, we're multiplying by 2. What do you normally do when you solve an equation? You divide by 2. So you divide this side by 2, you divide that side by 2. When you do that, cosine of theta will equal -1. Now, here's where it gets different. So we need to find where cosine is -1. Now again, remember that cosine is the x values. If we look on our unit circle, we've got this one right here, which is the point -1, 0. That happens at pi for the angle. So this is actually, I mentioned earlier, most trig equations are going to have two answers. This is one of the few situations where there is, in fact, only one solution. We're going to get one solution, which is when theta is equal to pi. That would give us a cosine value of -1. And then if you double that and then subtract 3, that'll end up giving you -5 when all is said and done. So that is that example. Let's look at this next one. 2 sine of x plus 1 is equal to 0. Now again, what would you normally do? If you're adding 1, you would subtract 1. Okay, so 2 times sine of x is going to equal -1. Then, since you're multiplying by 2, you would divide by 2. That gives me sine of x is equal to -1/2. Now, on our unit circle, where is sine going to be -1/2? Well, that's going to be this one down here, or that one down there. Here's -1/2. Here's -1/2. Those are both going to be angles that are over 6. This one down here, that one is going to be 7 pi over 6. It's pi over 6 past the pi mark, or 6 pi over 6. And then if we want this one, if you back up pi over 6, and this is 2 pi, also known as 12 pi over 6, that just means you're a single pi over 6 shy of 12. That means you have 11 pi over 6. And so then this is sort of typical. This is what happens most of the time when you're solving a trig equation. You're going to have two main solutions. And the solutions are going to be 7 pi over 6 and 11 pi over 6. This is x. That's sort of a standard garden variety problem there where you end up with two solutions. So a lot of what you do, the way you start these problems is very similar to how you would solve an equation. Like you would just an old-fashioned algebra equation. There's just extra steps at the end for what you do to solve for the sine or the cosine. Here we have another one. Again, notice that the range is, or the domain rather, is limited from 0 to 2 pi. Here we've got sine squared. So let's take a look at this one here, shall we? Two times sine squared of theta minus 1 is equal to 0. What do you normally do? Well, since you're subtracting 1, you want to add 1. 2 sine squared theta equals 1. Then you divide everything by 2. That's going to give you sine squared theta equals 1/2. Now, what happens because it's squared? Well, to get rid of squaring something, you need to do the square root, yes? And you may remember this from back in the day, but when you take the square root to solve for the equation, you get both a positive root and a negative root. So if you square root both sides, you're going to have sine of theta. That's going to equal plus or minus the square root of 1/2. Now, what, pray tell, is the square root of 1/2? Well, if you're doing the square root of 1/2, that's the same as the square root of 1 over the square root of 2. Fun fact, the square root of 1 is just the number 1. And then if you rationalize the denominator, this should look kind of sort of familiar, because if you rationalize that, that's going to give you square root of 2 over 2. That is what sine of theta is equal to. Now we're ready to break out the unit circle and figure out where this would be. And so since you have both positive and negative, you're going to get basically all 4 possible quadrants here. You're going to have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And the way I remember the ones over 4 is you're just counting odd numbers in order. You've got 1, 3, 5, 7. You're working your way around. So this one has a negative root 2 over 2. This one has a negative root 2 over 2. This one here is positive root 2 over 2. And this one over here is positive root 2 over 2. So each of those then gives its own pair of solutions. So when all is said and done, there are in fact 4 different solutions, because positive root 2 over 2 gives 2 answers and negative root 2 over 2 gives 2 answers. So if we list them all out, we're going to have pi over 4, 3 pi over 4, 5 pi over 4, and then 7 pi over 4. Okay, so that is that one. We're going to copy this slide because it was naively optimistic to think I would fit both of these examples on one slide, but it is what it is. So let's see. So we've done that. So we're going to do this. Let's erase this stuff. Okay. So yet again, though, this one's actually kind of an oddball. You notice they're actually going from 0 to 4 pi. That's kind of unusual, but it is what it is. All right, so let's take a look at this problem here, shall we? This is example number 5. We've already done that one. So cosecant of theta is equal to -2. Recall that cosecant, let's see. So 1 over sine theta is equivalent to cosecant theta. So what we can do is if we take the reciprocal on both sides, we can get something that we're a little more accustomed to working with. This would mean that sine of theta would equal -1/2. Now, a few minutes ago, I think we already solved for sine theta equaling -1/2. We found, what was it? It was 7 pi over 6 and 11 pi over 6. That's the two basic solutions. We found those earlier. But then here, just notice they're kind of throwing a curveball at us. We actually need to go all the way up to 4 pi, which basically means 2 times around. So what we're going to do is if you add 2 pi to each of these solutions here, and fun fact, you need a common denominator to do that. So what we're going to do is we need to multiply this by 6 on top and on bottom. This is going to give you 7 pi over 6 plus 12 pi over 6, which is going to give me 19 pi over 6. That is yet another solution, the second time around the circle. Meanwhile, if we take 11 pi over 6 and add 12 pi over 6, that will give us our last solution, which will be 23 pi over 6. And so when all is said and done, there turn out to be 4 answers. There are 2 from the first turn around the circle, and then there are 2 more from the second turn around the circle. And so we end up with 4 answers all told. That's kind of an unusual one. It's very rare that you're asked to solve from like 0 to 4 pi. Usually they just do 0 to 2 pi, but there's nothing that says you can't do multiple turns around the circle. Okay, let's see what else we have going on here. So here's one involving tangents. They say the tangent of theta minus pi over 2 is equal to 1. And here we're going from 0 to 2 pi. So where, pray tell, is tangent equal to 1? Well, tangent will be 1. Remember that tangent is the sine divided by the cosine. So if tangent is 1, that's another way of saying sine and cosine have to equal the same number, because the only way you get 1 from dividing is if you take something and divide it by itself, which basically means this has to be root 2 over 2, and that has to be root 2 over 2. The other possibility is you could be down here, because you could have negative root 2 over 2 here and negative root 2 over 2 there. And then the two negatives, when they divide, end up giving you a positive. This is going to happen when this one is pi over 4. And this one down here, here's 1, 3, 5. This is 5 pi over 4, because you just count by numbers. So the stuff inside the theta minus pi over 2, that is equal to these two values. So theta minus pi over 2 is going to equal either pi over 4, or the other possibility is theta minus pi over 2 is going to equal 5 pi over 4. So we got rid of tangent and we cracked open the trig function, found the angles that whatever is inside it would have to be equal to. And now what we're going to do, since we are subtracting pi over 2 inside the parentheses, once we have found the angle, now we're ready to solve by adding pi over 2 to both of these. So we're going to add pi over 2 over there. We're going to add pi over 2 over here. And we're going to do it over here as well. So what is this? This is going to be, and let's get ourselves a common denominator, because I can tell you right now we're going to need it. These are going to need to be over 4. This is going to be pi over 4 plus 2 pi over 4. And then this one is going to be 5 pi over 4 plus 2 pi over 4. And so when we do that, this one, 1 plus 2 is going to be 3 pi over 4. This one over here, 5 plus 2 is 7 pi over 4. And there you go. We have two solutions for that problem. Okay, what else do we have going on here? Find all solutions for tangent of x is equal to root 3. All right, well, so tangent of, and this, by the way, is all solutions, you'll note. So if tangent of x is sine over cosine, if this is the square root of 3, we basically have square root of 3 over 1, which where that would come from is if you did root 3 over 2 divided by a half. And fun fact, sine of x equals root 3 over 2. The angles where that happens. So here's root 3 over 2, which is across from a 60-degree angle, also known as pi over 3. And then the one over on the other side, that is going to be 2 pi over 3. So, and that's it. But, well, we also need, okay, so we have this. And then here again, they're saying all solutions. So what that means is that we need to add additional turns around the circle in order to get what we are after. So this means that x is going to be 2 pi over 3 plus 2k pi. And then it's also going to be pi over 3 plus 2k pi. Actually, hold on. This is not correct because this is tangent. Sorry about that. Let's back up a second. This is 1/2. And then what we actually need is this would need to be negative root 3 over 2, and this would need to be negative a half because the tangent does need to be positive. So this one actually, let's erase that. So this one here, that's actually 4 pi over 3. Now, fun fact. Come on. All right. This right here is plus pi right there. Recall that the period of tangent is pi. So tan has a period of pi. So it turns out that you can actually shorten this answer up. This is something that's special about tangent, because tangent, you can actually say this is pi over 3 plus k pi, because you can actually just go half turns around and get all of the solutions, including the secondary one from the unit circle, 4 pi over 3. So tangent is a special one where you can actually just add multiples of pi, and that will give you all the possible solutions that you could want. This is unique to tangent, and the only reason you can get away with this has to do with the period of the function itself. Tangent's period is pi, which is why you add k pi. For sine and cosine, their period is 2 pi, which is why you have to add 2k pi to find all the possible solutions when it's sine or cosine. Okay. What else do we have going on here? So they say find all exact solutions to the equation 2 times tangent x plus 3 equals 5 plus tangent x. And yet again, we are limited to just 0 to 2 pi. Here's what I'm going to do. You notice I'm multiplying by 2 here. Let's do the distributive property, shall we? 2 times tangent x plus 6 equals 5 plus tangent x. Now, what would you normally do if you had a variable on both sides of the equation? Well, you would subtract that unknown from both sides. So what I will do is I will subtract tangent x from both sides of this equation. 2 tangents minus 1 tangent is just a single tangent, tangent x, plus 6 is equal to 5. Then, since I'm adding 6, what do you normally do? You subtract 6. Okay, fair enough. Tangent of x is equal to -1. We talked about when tangent equaled 1 earlier. Tangent's going to be -1 in this quadrant and that quadrant. If you remember the little memory trick, all students take calculus. Tangent is positive here, and all of them are positive there. So then you need quadrants 2 and 4 to get either a negative sign or a negative cosine. And this is going to be where tangent is negative. This is going to be √2/2, and then a negative √2/2 for the x's. Alternatively, this is √2/2 with a negative √2/2 for the y's. And either way you do it, if you have a negative and a positive being divided, your answer is negative. These happen at the pi over 4 values. This one's 3 pi over 4. This one down here is 7 pi over 4. And again, you just count by odd numbers, 1, 3, 5, 7. And so the two solutions for this one, and we're not giving all of them this time, we're only giving these two. 3 pi over 4 and 7 pi over 4. Which you will also notice are pi radians apart. They are a half turn apart from each other. Use a calculator to solve the equation sine theta equals 0.8, where theta is in radians. So let's start by finding the main solution. The way you would do this is theta would equal the sine inverse of 0.8. So let's find where that will be. Get ourselves a calculator here. So if I do the sine inverse of 0.8, that is going to give me, I'm in degree mode, let's switch it to radians. In radians, that's going to be 0.9273. That is 0.9273. So that's going to be somewhere over here. It's going to be 0.9273. This right here is pi over 2. Pi over 2 is roughly 1.6. let's see, pi divided by 2, it's about 1.57 roughly. So over here somewhere is the second solution that gives us 0.8 for the y value. So we have another one over here where it's 0.8. And what we need to do, this angle is going to be also 0.93-ish. And what we need to find is that angle. If this is pi, it's going to be pi minus 0.9273. So if we do that, that will give us our second solution. Let's see here. So we're going to do pi minus sine inverse of 0.8. And that gives me 2.4242.
You didn't put inverse.
I'm sorry?
You didn't put inverse sign in the calculator.
Oh, yes, thank you. Let's try that again. So pi minus, sine inverse of 0.8. There we go. So that's actually 2.2143. All right, so 2.2143. So that is the second solution. This is the first solution. As before with the other ones, there are two solutions that you're going to be looking for. In very, very rare cases, will there only be one solution? Most of the time, especially if you're only doing one turnaround, usually there are going to be two different solutions when you solve a trig equation. All right, let's see what we have next. Here they say solve cosine theta equals negative 0.2. So we're going to do something similar to what we did earlier. So if it's a negative cosine, that's going to put us over here somewhere. This is going to be negative 0.2. And then there will be a secondary solution that's going to be down here somewhere. So what we need to do is we need to do cosine inverse of negative 0.2. So that's what theta will be. Let's find out what theta equals when we do this. So let's see. Cosine of negative 0.2, cosine inverse of negative 0.2, that is 1.7722. So that angle is 1.7722 roughly. That makes sense, by the way. Remember that this was about 1.57 for pi over 2. This is pi, meaning it's 3.14. So 1.77 would be somewhere between those two numbers. Now, if we want to find this angle here, so our goal is to find that angle. That's what we want to find. Now this going the other direction will also be 1.7722. So if I do a full turn minus that, if I do 2 pi minus 1.7722, that will give me this larger angle that's going to put me down in the third quadrant. So let's find out what 2 pi minus that value is. 2 pi minus the answer I just obtained. That is 4.5110. Let's see, this is 2 pi, which is like 6.28. So 4.5 is going to be somewhere between there and there. This incidentally is 3 pi over 2. it's good to have reference numbers, just to kind of know what you're looking for. So if I do 3 pi divided by 2, that's like 4.7 roughly. I think 4.71 it said. Yeah. So anyway, the point is, this is 3.14, this is 4.71. 4.51 is somewhere between those, which makes sense. That is what that is in the right ballpark for what that should be. So when you're finished, the two solutions that you end up with, because again, most trig problems, you're going to end up with two solutions here. You're going to have 1.7722 and you're going to have 4.5110. They didn't specify to give all solutions or whether it's just 0 to 2 pi. I'm mainly going to focus on 0 to 2 pi and just kind of leave it at that. So we have these solutions for that pair of values. Here's one. They say solve the equation exactly. Cosine squared theta plus 3 cosine theta minus 1 equals 0. And again, we're limiting it to just one turn around. We've got from 0 to 2 pi here. Now, this problem probably looks a little intimidating at first. What we're going to do is we're going to do a substitution to make our lives easier and maybe turn this into something that we recognize. Let's just pick our favorite variable x and let's set x equal to, oh, I don't know, how about cosine theta? So if I do that, what's this problem going to turn into? Well, instead of cosine squared theta, this is x squared. Instead of 3 times cosine, it's going to be 3 times x. And then minus 1 equals 0. That should look kind of familiar because that is actually a quadratic formula problem. You could try factoring it, but I can tell you right now that that is not going to factor into something neat and tidy. So let's break out the quadratic formula here. We're going to have negative b plus or minus the square root of b squared minus 4ac all divided by 2 times a. In this problem, a will be 1, b will be 3, c will equal negative 1. And let's see what this is. This is negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 1, all divided by 2 times 1. And what is that? That's going to be 9. That's going to be positive 4. Excuse me. And then that's going to give you negative 3 plus or minus the square root of 13 all over 2. My goodness. Okay. There's no two ways about it. This one, we're just going to have to approximate with decimals because there's not going to be a way to evaluate this exactly. Let's do this once where we add. And then we will do it again where we subtract. And let's see what that gives us. So we've got negative 3 plus the square root of 13 all over 2. That in parentheses so that the whole thing gets divided. Okay, that is going to be 0.3028 if I round it off. So this means sine of cosine, not sine, cosine, because that's what we used to begin with. So cosine of theta is going to equal 0.3028, and theta is going to be the cosine inverse of that number. So let us find out what that's going to be. So we're going to do the cosine inverse of the answer that I just got. And that is 1.26 radians. And then like we did before, 1.26 is that is 1.26. And then there's going to be a, let's see, it's actually going to be down in the fourth quadrant, because we need where cosine is positive, because both of these are an x value of 0.3028. So then to find this angle, it's going to be 2 pi minus 1.26, which is going to give me the other solution from this one. So 2 pi minus that answer is 5.02. So that answer just by itself gave me 2 solutions. Now we need to see what this is going to be when I subtract the square root of 13. So let's go back to the calculator here. We're going to do -3 minus the square root of 13. Click over here and close the parentheses, divide by 2. That gives you -3.3. We'll just round that off at -3.3. Fun fact, cosine can only be from -1 to +1. So it is impossible to get a cosine of -3.3. If you try to do cosine inverse of that, your calculator is going to give you an error message for good reason, because that is impossible. The lowest possible number you can ever get from cosine, and also sine, by the way, it's true for both of them. The lowest possible number you can ever get is -1. -3.3 is not within bounds. It's too small of a number. So basically what we're going to do is we're going to throw this out, and there are in fact 2 solutions when all is said and done, which is 1.26 and 5.02. All right. Let's stop there and take a short break. I'm going to start up again at 8 o'clock. So let's take ourselves a short break, and we'll start up again at 8 and finish off this section.